Did anybody get a message from me?
Yes, I received the email.
Did you, Amanda? Did it
Mhm.
was it accurate? Say everything right?
Yes, seemed pretty clear.
Very good. All right. Amanda, how was your weekend?
Tried to do some relaxation, but also rewatch some of our recordings. So thank you, Hunter, for having those available.
Hunter, are you there, Hunter? Would you be willing to contact a person? The lady's name is Edith Narro. I'm gonna give you her email. I think I can do that. You ready? It's NARROEDITH at yahoo.com. Narrow. It's NARRO. There's no V. Then Edith at yahoo.com. I'm gonna appreciate that. Thank you. Let's. She just wants to know how to get access to these. Yeah. So here's Gabriel Mulvaney saying the same. Let's see. Hernandez. Zero. All right, let's see. There's a Rebecca trying to get on board. She might be going to the wrong site. I think tonight, can someone check their syllabus? But mine says you have one section to do tonight. It's called 1.7. Is that what anybody can give me a confirmation on that?
That's what mine says.
Okay, so you guys, we might, to save time, we might do two. Now, why would we do two? Then sometime in the future, maybe we can have a day off. Does that make sense? Let's see how tonight goes. If it only takes like 25 or 30 minutes, I think that's the best way to go. But I'll let you guys decide. We'll see. So we still need this Rebecca to contact me. Okay. Let me start doing some attendance stuff here. We'll see if this phone rings. Okay. Maybe it did. No. All right. So, Amanda, wait, here it is. Stuck awake. Hello? Yes. Wait, I can't understand. Time out. What did you say? I hear a lot of stuff in the background. Let me ask you guys, are you signing in to 1314, right? Yeah, there's only one 13, 14, 31, 704. Okay. In finishing, you're going to 13, 14 on the left hand side. There's a menu bar and it says online class meeting. And you click that. And what do you get? Okay. On the far right, you, you sign in. Are you there? Okay. Can I give your phone number to a person that can help you? Okay, hold on. Would any of you out there be willing to help this lady get in? She doesn't, and I need to start class. Does that make sense? Would anybody be willing?
I can try.
Marissa,
Yes.
let me give you her phone number. She said it's all right. 972
Okay.
940
Okay.
1259.
Okay.
All right, bye bye. Okay, so Alma Garcia, you're here.
Here.
And I show you've never missed. And I forgot to write down something you told me about you. What is something you want me to know about you, Alma?
Um, I was in swimming.
Hold on for a second. You're in swimming. You there, Alma?
Yes, like during my
You're a
free time.
okay.
Yes. I like to paint and draw,
Paint and draw.
and I have a part-time job.
What do you do?
I work at Bath and Body Works.
That's good. Good for you. All right. So Amanda, you're here.
Yes, I am.
You still working at Best Buy?
Last I remember.
Okay. Angelica?
I'm here.
Gotcha. Dylan? Dylan, you're supposed to be here. Okay, Dylan. Uh, Emma, I got you, Dylan.
Yeah, I'm here.
How are you doing these days?
I'm doing good. How are you?
Good. Thanks for asking. Erica Whitehead, are you here?
I'm here.
How are the three children?
Great. Thanks for asking.
Gabriel Mulvaney.
Hello, I'm here.
Gotcha. Holly,
I'm here.
you been shopping lately?
Yeah. I just went today, actually.
Yeah, I went shopping today. I bought stuff I really didn't need, but I knew I was getting paid, so I just did it.
Yeah, we've all been there.
I got Hunter. Hunter, you're doing great. Jamie Anderson. Nikki.
I'm here.
Nikki, is that right?
Yes, sir.
You travel anywhere this past weekend?
I leave for Puerto Rico for 6 days on Friday, so
Are you kidding me?
no.
Are you going to be taking this then down there on the internet?
Well, we're off on Monday, so I'll be back. I leave Friday and I come back Wednesday, so I'm gonna leave the computer at home.
Jamie,
Well,
all
we're
right.
off. We're off for the holiday on Monday, right?
Well, yeah.
So see, I'll just
Jennifer. All right, Jennifer, are you there?
Yes, I'm here.
Gotcha. Joshua.
Yeah, I'm here.
Joshua, I don't have anything on you. Tell me what I need to know about you, or should be fun to know about you, or something.
I
Where you
love to
work.
fish.
Yeah, are you catching any fish these days?
I haven't gone in about a month, but in the fall
When
is
you
mostly
go,
when they catch.
when do you go?
Uh,
Where?
in October, mostly in Lake Tyler.
Okay. Lillian. Lillian. Rebecca, you're finally here. Can you talk, Rebecca? Rebecca, are you there? Well, Rebecca, it shows that you got here last time, so I'm thinking you should be here. Are you still there now, Rebecca? Hello, Rebecca. All right, Rebecca. No. Let's see. Lillian, did I just get through talking to you?
I'm here.
What do you know, Lillian? Anything?
What'd you say?
How are your dogs doing?
One of them moved with my mother and she got a house, so he's pretty upset, but he's okay.
You got one dog then?
Yep, one dog left.
Two cats.
Uh-huh.
All right. Marissa.
I'm here.
Just for my record, I don't have anything about you either. I won't bother anymore, but I'll ask you the last for. Tell me something about you.
I have 2 kids and I work in my dad's business. He does masonry, so I help him with that.
Cement. He's a cement guy?
Brick.
Wow. So do you lay bricks then yourself?
No, more of the managing side.
Okay. Two children, boy, girl?
Boy and girl, yes. My boy is 5 years old, and then the girl is 11 months.
11 months.
Yep. And I have 2 schnauzers.
Really?
Yeah.
Two?
Yeah, 2.
No, they're dogs. How come two?
Just so we can later, they have company, and then later we're gonna breed.
I got you. I got you. All right, I got you down. Let's see. Monica Hickson, are you there?
Here.
I'll call on you next time. We're getting a lot of feedback from you, Monica.
That's not me. I don't know who that anonymous caller is.
Somebody.
I think it's me. Can you hear me now?
Who is this?
This is Rebecca.
You gotta hang up and read. You're on the phone trying to come in, yeah. Ooh. Who is the anonymous caller?
That's me.
Who is that?
It's Rebecca.
I'm gonna have to ask you to disconnect.
Okay.
Anonymous caller, you have to come back in.
Okay.
I don't know who you are.
This is Rebecca Calzada.
You came in a different way. You gotta try something else, Rebecca.
Okay, I'll try again.
You're okay. You got the phone on plus this, I think maybe. All right. So I got Rebecca. How about Rosio? Rosio, are you
I'm here.
are you the one that helped her?
No.
Okay, thank you, Rosio. Ryan. No, Ryan. Ryan Clouch, no here.
I'm here. My mic took a second to come on. Sorry.
You're good, Ryan. You know, I'm kind of get some Domino pizza from you one of these days. Sharon, are you ready?
Yes, sir.
Good deal. Vanessa. Vanessa, I guess you're here. And Vincencio.
Yeah, I'm here.
I got you. You're good. All right, so we're going to start the class, the meeting. Again, everybody should know that that the hunter is recording these, and so if you can't make it and you watch the recording and you tell me you do, that counts. But I'll share with you that on the midterm, it shows up if what you tell me is true, pretty much. So be careful. Really do it if you do it, and sure, and everyone should get a study buddy. Okay, enough of
Were
that
you
said.
able to count me as here, Monica Hickson?
Monica,
Yeah, the anonymous caller messed up my roll call. Just to make sure
Monica,
you wasn't.
I did count you in. Is that okay, or did you not?
No, that's perfect. Thank you.
Monica, after all that, this shows you've come twice. Do you know how to get in now?
No, I that wasn't me. I wasn't an anonymous caller. I was trying to say here when the anonymous caller clicked in,
Oh,
but I've
okay.
been here.
Hey, I got you. I got you. Okay, so we'll go back now. We're going to go to the book. I already brought the book up, so here it's on 1.7. You all should be able to see the book. Can I get an amen on that?
We can see it. I can see it.
Yep.
Thank you. Okay, so most of this chapter deals with graphing. So in a nutshell, in summary, with all this other stuff going on, if I write this on a graph, that's a straight line. Pretty straight, huh? And this is like 5, and this is like a -5. And I want to show, this is 0. If I want to show this right here, and I want to include that somebody's got to put, Amanda, you got to put your machine on mute, I think. So you got to have a bracket and a bracket like this when you graph it. So if it includes this, this would be a bracket. Now, in interval notation, it would look like this: -5, correction. It'd look like this, bracket. It's a bracket when it includes the 5s like this. Now, if I had the same line, a little straighter, we'll make this one 6. Then this a -6. And let's say it did not include that. That would look like this in parentheses: -6, comma 6. Now, the other thing that I want to share with you is this. So if it doesn't include it, it's parentheses. The other really important thing is that students get mixed up sometimes is infinity. If infinity is positive, so if you have like this 6 and it goes on and on like this, the 6 goes on the left. And if this was a bracket, this would be a bracket. But anytime you have an infinity, it's a parenthesis. Pretty messy there. Let's do it the other way. Let's say this is -6, and we want all the solution to go the other direction. So -6, and we're including the -6 because it's a bracket. It would represent the same thing in interval notation. This is graphical notation at the top. And the negative infinity would be on the left-hand side. And negative infinity is also a parenthesis. So positive is on the right, negative is on the left. And infinity is always a parenthesis. Now, let's go to the book. We really haven't gotten to the first problem yet. They're just giving you some information here. This is on page 190 is very specific. The graph and the interval notation. Now, the set builder notation, you should see that and note it, but it's not used very often. I don't want you to take it lightly, but you should understand that's how it's written. Usually, you'll see a graph or interval for the test. Now, here we go. Number one. All that was preliminary stuff. You might say, geez, you thought that was half the class. But now it should be easier. Look at A. They want us to show A, so it's a parenthesis for -1 and a bracket for 4. Let's skip to C. A parenthesis for -4, and it goes all the way in infinity to the right. Notice on the graph, it's an arrow and it just keeps on going. Interval notation, the infinity sign is on the right. They don't write plus infinity. It's just known to be plus without anything. Anytime you have questions, let me know. Now they're going to do an intersection thing. Let's just do A. So the first graph is 1 through 4. You can see it. It's in blue. It does not include the 1 or the 4. The second graph is 2 through 8. It includes both the 2 and 8 because it's designated with a bracket. They want to know what the intersection is. The overlapping part is it's got the 2 and it goes to 4 because it does not include the 4. The solution is at the bottom of the page, graphically, and in interval notation. Notice why I say use graph and interval notation, because it looks almost the same thing. You can see 2 and 4 and 2 and 4. Are there any questions about this particular problem? Because this is really the meat of it. Can anybody hear me? We still good?
Yeah, you're good.
Okay. Thank you. I appreciate it. At least someone let me know, and appreciate that. Let's go to the next problem. Now, this is a linear equation. They get more complicated. This is rather an easy one. Remember, the goal is to always get x by itself. Now, in front of you, if I could get someone to mute that. In front of you, you'll see a problem that the book does, in my view, correctly, but not in the best interest of the students. Notice they have some red down there where the direction changes of the less than and greater sign. Let me show you this, because I can do this in such a manner that you don't need to do that. They give you the problem 3 minus 2x is less than or equal to 11. Now, the way to do this problem, in my opinion, is always keep your x's positive. So I'm going to push this to the other side, over here. And I'm going to push this to this side, over here. That's going to give me 3 minus 11 is less than or equal to 2x. Why? Because I have to subtract 11 on this side. I have to subtract it on this side. Sharon, I'm getting a lot of feedback. Can you make sure your end is at least muted? Thank you, Sharon. Now, the next thing is 3 minus 11 is what? -8 is less than or equal to 2x. Divide both sides by 2 because I want to get x by itself. I have x is greater than or equal to -4, 8/2. Now notice we did this in 1, 2, 3 steps. We did not change any of the directions at all of these signs. Let's go to the book. Notice what the book is. We had x is greater than or equal to -4, or -4 is less. Let's just verify it's exactly what we said. Let's go back to it. You can see x is greater than or equal to -4. That's what this says. Or -4 is less than that. Go back to the book, verify that. X is greater than or equal to -4. You can write it either way. We are correct. But notice they had 1, 2, 3, 4 before they got to the solution 2. What they did, and I want to point this out because you have to know how to do this too. First of all, they're trying to get x by itself. So they subtract the 3 from both sides. You have -2x is less than or equal to 8. But they divided by a negative number. Anytime you divide by a negative number, the signs switch. But if you add or subtract, they don't. So in this particular case, the signs had to change. Notice, in our particular problem, which I hope is seeable, they never changed at all. None. Why? Because we made the 2x positive, we added it to the other side. We did not multiply it by a -1, we pushed it to the other side, which changes it. Well, anyway, let's go to the next one. Just wanted you to see the difference. I always try to keep my x's positive. Now look at this one here. -2x is, and let me again do this one, I think the best way. I'll slowly do this one so it'll be maybe more helpful. -2x minus 4 is greater than x plus 5. We'll go back and we'll do it slowly. And most students probably know how to do this by now, but I want to do it one more time. Try to be a little neater. -2x minus 4. I'm surprised myself. It looks pretty good. Greater than, I'll ruin it here in a minute, x plus 5. Now, if we push the 2x to the other side, if we just add 2x, we're going to get -4 is greater than x plus 2x plus 5. At the same time, we're going to push this to the other side. To do that, we have to subtract 5. We do that to the right, we have to do it to the left. We get -5 minus 4 is greater than 3x. -9 is greater than 3x because you add those because they're both negative. If you lose $5 and lose 4 or more, you've lost 9. Divide by 3. Anything over itself is 1. So you get 1x. This becomes a -3. So x in this case is less than -3. So here in your number line, this is 0, -3. If x is less than -3 and it does not include 3, you put a parenthesis and it would go like this. -3, parenthesis, and then -infinity. There you go. That's it. That's what the book should show. And let's see if we'll get the same answer. Let's take a look. X is less than -3. Boom. Now, in this case, the way I did it, you did not have to flip the signs. The way they did it, you have to, because they divided the x portion by a -3. We added it to the other side to make it positive. My rule is always try to keep your x's positive. You can take that any way you want. Number 5. I'm going to show you number 5. This is exactly what's on
That
the
was a
test.
good one.
Yeah. I hope you got that. Some people can get that one, but let's take a look here. I don't like the way the book does this one either. Let me show you my way to do it, which is kind of like theirs, but much easier. Let me get a piece of scrap paper here, better situated. Okay. So we have x plus 3 all over 4. I should just pull my book out, but I'm too lazy, I guess. X minus 2 over 3 plus 1 over 4. So we do this. Most of you all have books probably, but just in case you don't have it open like I don't, I'll write the problem again. You have x plus 3. This is all over 4. Is greater than or equal to x minus 2 all over 3 plus 1/4. Now, the rule in math is as long as there's an equal sign or greater than sign, if you can get rid of the denominators or get the denominators to match, they're not fractions anymore. So if I look at 3, 4, and 4, the common d, what is the common denominator here?
12.
It is. So what do I have to do to in the first case where the denominator is 4? How do I make that bottom 12? What do I got to do to 4 to make it to be 12? Multiply it by what?
The reciprocal.
Multiply by 3.
But what do you got to multiply 4 by to make it
3.
go away? Yes. No. What do you got to multiply it by? Yeah. Did somebody say 3?
Yes.
Yeah, that's right. If you multiply the bottom by 3, it becomes 12. So whatever you do the bottom, you got to do the top. I usually have someone help me because with attendance, because I can't see when people come in. But okay, so what do you do to the second part where you have 3 over here? What do you got to multiply that 3 by to make it
4.
12? So you got to multiply the top by 4. And what do you got to multiply this 1 by to make that, or this 4 by to get it to be 12?
3.
That's right. So now we have no denominator because they're all the same, but the top now becomes 3x plus 9 is greater than or equal to 4x minus 8, because you take this times this, and this times this, this times this, and this times this, and then plus 3, because 3 times 1 is 3. If I keep my x's positive, I'm going to take 3 from here. I'm now going to have 9 is greater than equal to x minus 5, because a -5 and 3 is -5. How did I get the x? I subtracted 3x from this side. It goes away. But if I subtract 3x from this side, I have to subtract it from this side. That gives me a positive x. Now I want x to be positive and by itself. So I'm going to add 5 to the right. I'm going to add it to the left. That's going to be 14. So x is less than or equal to 14. Let's see if that's right. Yeah, there it is. Now, all the stuff above it was the steps they took. It's just too much for me, class. Again, I wouldn't do it that way. I would do it the way I just showed you. These are the steps that we took. We simply found the common d, which you can see in the right is 12. In order to make the first denominator 12, we multiply by 3. Whatever we do the bottom, we got to do the top. We show that right here. The second one, we had to multiply by 4. We did the top. third one multiplied by 3 again. Boom. 1, 2, 3, 4 steps, and we had the answer. If you look what they did, no offense, but it's significant. The steps are just tremendous. Now, solving a linear equation like in number 6. First of all, they multiply the left-hand side out using distribution property. 2 times x gives you 2x. 2 times 4 gives you 8. That's your second line in the solution A. Now notice you have 2x in both sides. You get 8 is greater than 3. Now, this is just kind of goofy. Why? Because what you're really seeing is this. They're hiding it, or maybe you can see it, but a lot of students don't. But let me show you this. If I have 2x here equals 2x here, everyone would say that is absolutely true. But if I put 5 plus 2x equals 2x plus 6, remember, whatever you do on the right, you got to do the left. So if I cancel 2x on the left, I cancel it on the right. 5 does not equal 6. And that's exactly what they did. And anytime you get a situation like that, there is no solution. And that's what it's going to say. Now, they're going to do another one. The other one is going to be this. Let's say I have x equals x. I'm going to add 5 to this side. I'm going to add 5 to this side. I'm going to add, well, I could just keep adding, but here's what they do. If I take away x on this side, I get 5 equals 5. That means everything works. So if I put in, again, this is the original equation. Most of y'all can see it. If I make x equals 2, well, 7 is going to equal 7. If I make x equals 3, then, 8 equals 8. If I make x equal 5, then everybody knows that, 5 and 5 is 10. To finish this off, if I say 8, that's 13 and 13. That changes to 8. We get 13 equals 13. That means everything works. That's all they're trying to keep you informed of. Now, they go through a lot of changes to make you see that. But the bottom line of A, you can see 8 is greater than 3. It's not. That part is true. It just doesn't equal it. So everything works here on this one. But if it was going to be an equal sign, it would be nothing works. I just wanted you to see that. So the solution for A is, in fact, 8 is greater than 3, and so it's a true statement. Now, solving compound equations. Earlier today, my class did this, and I want you to know, do not do it like the book shows you here. No, I'm not just trying to overrule the book. I'm trying to think I'm smart in the book. The book, in another chapter later, does not do it this way. They do it this way to show you that the book is smart. You can do it this way. Well, and that is, they're working simultaneous equations. I will teach you or recommend to you that you never do simultaneous equations, because later on they get too mixed up. You get them mixed up. I'm going to show you how to do this by breaking them down. I'll write the equation and share with you how to do this. One of my rules in class is you can't have a cell phone in class, because everybody wants to get on the cell phones. But tonight, I got some folks that might be trying to call me, so I got to make sure that. Hold on. Well, maybe I know who that is. Maybe they're already on board here. Let me check. Hold on. All right, that was good news. Now here's the problem I wanted to show you. The book gives you the problem -3 is less than 2x plus 1, which is less than or equal to a +3. They want you to solve this. You should always divide this up into two equations. -3 is less than 2x plus 1. So you pushed everything from this sign here this direction, which is the equation you see below. And then for the other one, you push everything here this direction. So now the other equation is 2x plus 1 is less than or equal to 3. Now you solve these. You push the 1 in the left-hand side to the left, you get -4 is less than 2x. Divide everything by 2, -2. X is greater than -2. On the right-hand side, subtract 1 from both sides, so now I have 2x is less than or equal to 3. Correction 2, because I subtracted 1 from both sides. Divide both sides by 2. I have x is less than or equal to 2. So here's our solution graphically. We have a -2, it's a parenthesis. We have a +2, and it's a bracket. Interval notation, you have a -2, parenthesis, to 2, bracket. So what I did is I divided the equation up. You can see how I did it. I drew the arrows. The book doesn't do it. And you're going to say, well, I like the way the book does it. I can work them both at the same time in my brain. Well, you might be able to do this one, but the problems they give you later on, if you follow the method they do, they become very difficult and challenging.
Dr. Wickman?
Yeah.
So why is it a parentheses on the negative side and then a bracket on the positive side again?
Good question. Because of this. It's only a
Oh, because
less
it's
than.
not the equal sign. Okay, got it.
Yeah, there it is.
And
Lillian,
then I thought, yes, sir.
that's a good question. What else?
I thought something divided by itself is 1.
It is. I made
So
a mistake. That's right. But it should be 1. Should be 1. Should be 1. Good catch. Thank you, Lillian, for not being too tough. I say, like, hey, you dummy, you got it wrong. Thank you for being nice. You're right. Okay. By the way, I did something like that once when I was getting my doctorate degree. I told somebody that they were like wrong, and I should have done it much more diplomatically. And I learned a great lesson. You never tell your boss you are an idiot. You might point out, say, boss, what do you think about this? And just to quick tell you the story. I'm working on my doctorate degree, and we're asked to look up some research. A guy by name Mikhail Csikszentmihalyi. He's an author out of Chicago. And the teacher was going to tell us what he meant about the article. So what I did is I called the guy, believe it or not, and spoke with him. And he told me everything he wanted me to know about his article. So then the next class, I was going to tell the professor that I called him and talking, but he started out saying, here's the article, and this is what he meant. And it wasn't what he meant. So I said to the professor, you're wrong, sir. He didn't. And he said, what do you mean I'm right? I know the guy, this is it. And then I said, well, you're still wrong. And he kind of got mad. I said, Dr. So-and-so, I recorded the conversation. Here's what he said. And I made a fool out of him. So I never will do that again. And it was a good lesson. But anyway, here's another one to solve. An absolute value equation. I'm going to show you the answer to this one too. So hopefully I can get my numbers right. And I'm going to show you the question on the exam, or a question like it on the exam. Pretty close. So in an absolute value equation, x minus 4 is less than 3. Now, you should know that if I have x squared equals 9, the answer is always going to be plus or minus. In this case, it's 3. In an absolute value situation, it's always going to be plus or minus. So you have x minus 4 is less than 3. And then you have x minus 4 is greater than 3. Well, let me correct that, because I think there's even a better way. Hold on. Well, we'll solve it like this for now. So you have x is less than, so I didn't put the -3 here. Yeah, I didn't do that right. Let me just, this should be x minus 4. Yeah, let me show you this again. Don't pay attention. All right. For some reason in my brain, here you go. X minus 4 is less than 3, and x minus 4 is less than, when you make this a -3, it changes signs. Boom, like this. So let's solve it then. X minus 4 is less than 3. Add 4 to both sides. X is less than 7. That's that solution. This, you have now x minus 4 rewritten, is greater than -3. Add 4 to both sides. X is greater than 1. Add 4 here, 4 here, 4 minus 1 is 1. So x is less than 7 and greater than 1. So you have 1 on the graph and 7 parentheses. Parentheses is a solution. 1 and 7 like this is a solution. What I did is I made one 3 and one -3. Let's see if that's what the book says. I think that's correct. Yeah, x is greater than 1 and less than 7. Notice that this time, they still did simultaneous equations. I broke them apart. Solving another absolute value equation. This is number 9. Now, to solve this problem, there are also some tricks to this. But before we do that, I have to show you the test problem, because I promised you I would, or one similar. But let me assure you, it's enough information where you will get it right. And don't worry, if you come to the review, you'll get the same thing, so you won't miss anything much. Not too much. So here we go. Here's the test one. So I'll say you have an absolute value of x plus 5 is equal to a -7. So you might think you can solve this by saying plus or minus. That you would have then x plus 5 is equal to a +7. You would be absolutely wrong. Why? Because an absolute value machine can only produce what kind of numbers?
Positive?
Exactly, Lillian. And this was a negative number. So their answer to this, there is no solution. There is none. There's no number you can put in there for x to get a -7. None. Now, let's go to the next problem on the book. And that was this one. I gave you a -2, absolute value of 3x plus 5, closed absolute value, plus 7 is greater than or equal to a -13. Now, in order to do an absolute value problem, you have to push this 7 to the other side. So now I have -2, because you can't do an absolute value unless it's pure absolute value. So you have -2 times 3x plus 5 is greater than or equal to a -20. You can divide by a -2, which then gives you an absolute value of 3x plus 5 is greater than or equal to 10. Now you break it up is 3x plus 5 is greater than or equal to 10, or 3x plus 5 is greater than or equal to, correction, less than or equal to, because it's a -10. So this would give you 3x is greater than or equal to 5 here, because you subtract 5 from both sides. This one here is 3x is less than or equal to a -15. This gives you x is less than or equal to a -5. You can divide both sides by 3. Anything over itself is 1, that's 5. This one we divide by 3, x is greater than or equal to 5/3. So there's your solution. X is greater than or equal to 5/3, and x is less than or equal to -5. Let's see what that looks like. X is greater than -5 and less than or equal to 5/3. Looks like this graph in the green line. Notice again, they worked this simultaneously, and I didn't. Does that make sense? Are you guys okay with that?
Yes.
So if you guys work them separately, you will always be better off, even though the book hasn't changed yet, but they will. Now here, 5 minus 2x is greater than 7. Here is what they do now. Look, they give you a separate equation. 5 minus 2 is less than or equal to -7, or 5 minus 2 is greater than 7. They break them down now. They do not work them simultaneously. Let me do this again for you. I'll try to do it neater. 5 minus 2x is greater than 7. And we'll come up with a solution. Can everybody see this one? 5 minus 2x is greater than 7?
Yes.
Okay, so I'm not rewriting this the whole thing. I'm going to do the -7. So we have to remember 5 minus 2x is less than or equal to -7. Why? When you change the sign to negative, you have to change the direction. Now we can solve this. I'm going to put 5 on the other side. I'll have -2x is greater than 2, because you subtract 2 from both sides, or 5 from both sides. If I divide this by a -2, well, look, hey, this is the best way to do this. I'll put 2 over here, -2 over here, and 2x here. So if I add 2x to this side, I have to add 2x to the other side, subtract 2 from the right, I have to do 2 from the left. If I divide this by a -2 or a +2 on the right, I get x, and I get -1 here. Now, this is what I came up with left-hand side. Now, let's do it this way. Same problem, same thing. 5 minus 2x. This is just the half side. If I subtract that from both sides, I get negative 2x is greater than 2. If I subtract, excuse me, if I divide by a negative 2 here, I have to switch sides again. So we have x is less than a negative 1. So it's the same thing. This is x is less than a negative 1, and this is just two ways of doing it. One is I kept my x's positive. Here in this one, I'll do it this way. I'm going to leave the negative 2x on the side. It's still less than. Subtract 5 from both sides, this becomes a negative 12. If I divide this by a negative 2, which I have to get x by itself in positive, this changes direction. And then this is also divided by a negative 2, which means this becomes a positive 6. So you have x is less than negative 1, and x is greater than 6. So it's going to look like something like this. And let's see on the graph. So x is greater than 6, as you can see here, parenthesis in the green. X is less than negative 1 here. Again, they broke it apart. They worked it separately, just like I shared with you in the very beginning. Now, I don't know about you, but I love to rent a car and just take off for the weekend. To be honest, I don't always treat the rental company cars fairly, in the sense they always ask you, are you going to go out of state? And initially, I tell them no. Why? Because then they'll rent me the car. If I tell them I'm going to Arkansas or Oklahoma, I don't think about going to Mexico, because that's no insurance will cover you there. You've technically not been honest with them. And then to be honest, I tell myself, well, I don't think I'm going to go out of the state. So I try to follow the rules as best I can. So let's say I want to rent the car and just travel around Texas in accordance with the rules of the rental company. I'm given an option of $4 a day plus 15 cents a mile, or $20 a day and 5 cents per mile. The answer to this problem is clear. The more miles you drive, the better one charge is going to be versus the other. The issue with 11 is, how do you write this in equation? Well, here, you can always see it. This is the answer right here. You have $4 a day plus 15 cents a mile. That times how many miles you're going, and that's X. The other one is $20 a day plus 5 cents a mile, and that's X. Now, which one is the better deal? We're facing it towards the left, so that's going to be what? Acme. On the other side, I don't know, what did they tell you? It's, I don't know, a different company. We'll say Hertz or something. But you have two equations. Now, there's a couple ways to do this. They do it the old-fashioned way here. You have 4 plus 0.15 minus 0.05x is less than 20. And then what they did is they subtracted 0.05x on the right-hand side, which just leaves you 20. But if you subtract 0.05x on the right-hand side, you have to do it to the left. And that gives you 0.1. Now, to get x by itself, you subtract 4 from both sides. You get 0.1 is less than x 16. If you divide both of these by 0.1, 16 divided by 0.1 is 160. Let's see. Of course, you've got a good calculator. 16 divided by 0.1, boom, 160. Back to the book. The deal in the book now says, and I love these kind of problems because I don't want the cheapest deal for renting a car. If you're going to drive less than 160 miles, that means you can't even go to Waco and back. The best one's going to be the 15 cents and $4 a day deal. That's on the left-hand side. If you pick 160, they're equal. But if you go on the right-hand side, if you travel like 170 or 180, 200 miles, you're better getting the deal where you just pay $20 a day and 5 cents a mile. Now just going to be another tidbit of information. Some people will rent their car unlimited mileage for a certain amount or fee. That's the one I picked, where I can just drive and drive and drive, don't even have to worry about it. I'll go to the rental place, pick out a car, or tell them I want a car that I really want to enjoy driving, and go away for the weekend. Now, we got a holiday coming up. I just might do that. That was it for today. We've covered a lot. We didn't go to 9:20, but I'll give you a break. Are there any questions of me? Let me do this. I'll go through the attendance and just ask if you have any questions. If you do, I'll be glad to answer them. Just we want to remind and thank folks for being here, and also, of course, Hunter for recording them. So I'll just start out. Let me start out with names who I don't have, because maybe they came. Let me just have, let's see here. Mahogany Gillis, are you here? Nope. Torino Gillis, husband, wife. I've talked with him. They're watching the film. Jordan Guerrero, are you here, Jordan? Jordan usually can come. Lillian Holmes Hamcock, you're here, aren't you?
Yes, I'm here.
Reba, are you here? Reba Colson, are you here? I think you're here. Edith Nero, are you here? My teacher assistant, not here. Deviana Robinson, my nursing person. I think she said she couldn't be here. And that's everybody. So any questions, Alma? Anybody? Everybody else I got marked in. Anybody?
No.
So we have one more online meeting this week. That'll be Wednesday. Next week, Monday, you guys are off. So it's pretty cool. I don't have anything for anybody unless you have something for me. Everybody else that's here, if you're marked in. Indira, let me see.
I'm so sorry, Professor, because I have trouble in internet today, so I'm late like 30-45 minutes.
India, that's fine. You're good. I got you.
Sorry for today.
Appreciate your honesty. All right, you guys. I have I got Alma, Amanda, Angelica, Dylan, Emma, Erica, Gabriel, Holly, Hunter, Indira, Jamie, Jennifer, Joshua, Trejo, Lillian, Marissa, Monica, Kiba, Rebecca, Rosio, Ryan, Sharon, Vanessa, and Venancio. I have you all marked in. If you all don't have anything, me, I'll say also the least. Have a nice night. And it was just about an hour off.
Thank you.
Thank you. Good night.
Thank you. Happy night.
Appreciate you guys.
Thank you. Good night.
Thank you.
Good night.
Thank you.
Thank you all. Great group. Good group, guys. Thank you. Sharon, we can hear everybody in the back. You good?
Yes, I'm good, sir.
Thank
Thank
you.
you.
Bye-bye.
Bye bye. Have a good night.
You too.
A very good one. Bye bye.
Bye. All right, so I have Reba and Hunter. Hasta la vista, you guys. Bye, Hunter. Thank you.